Well, delighted to be here, and thank you everyone for your time today. Hopefully this will be things you haven't seen before. It's fairly contentious, some of the things that we're doing, and I appreciate from particularly from a regulatory point of view, there's a lot of questions, so I will leave some time at the end to take any of those questions, so please feel free just to come back at me at the end.
Just concerned your presentation isn't shown on the screen at the moment, but it is loaded.
Yeah.
I probably need to just close that background down. Yeah, just if I just click out.
Yep.
Where's the mouse gone? Why have I not on here? Okay, this is what you call a technical glitch, guys. If in doubt,
There they are.
kill it. There we go.
Perfect. And then on that one, all you need to do is hit full screen on this. That should be if it's mirrored. So,
there, away we go.
perfect. Cool. Okay, so you can see here, I mean, what I've done is kind of shorter, slightly snappier title than the first one, which is kind of industrial experience driving technical innovation, which is really what we've done as a business. So what I'm going to kind of do is walk you through the last 6 years of drones in critical, using them in critical infrastructure such as oil and gas, taking you to where we are today and what is actually being done right now, and then taking you forward to the stuff we're working on, which will be coming in over the next couple of years, which really is pretty exciting stuff. So back in, as you just heard, back in 2006, 2007, I was an end user of drones in Iraq and Afghanistan, and I was a platoon commander on the ground with the Grenadier Guards, and I was working with the Americans, and we had access to this amazing technology, these new drones. I was driving around Baghdad. I had an ordnance survey map from 1971. I had a satellite imagery map, which was about 6 months out of date, and then I had a drone map, which was awesome, which was from that morning, and just pieced together. We're using just normal stitching, photogrammetry, and I was using these three maps to tell me different things. Obviously, the OS map was giving me some, some of the kind of terrain that I needed to know. The satellite map showed me the permanent structures, and then the drone map showed me what had been occurring that morning, because people had been setting booby traps. And it was really using this information to get safely around Baghdad made me think that, do you know what, this drone data is incredible. Fast forward a year, I was in Afghanistan working with Americans again. Either someone really liked me or really didn't like me. And we were getting dropped into areas we'd never been in before, jumping out of Chinook helicopters. And before we go into these areas that no one had been in before, we'd fly the drones over maybe 4 or 5 times in a day. We'd use basic algorithms to see what had changed during the time on the ground. So if they'd been tipped off we were coming in, we would see different patterns of life, different things being built, movement on the ground. So it was really that was the whole concept for what we do today. So it's always been about the data. It's nothing to do with the hardware. That's just a really good way of getting new forms of data that we couldn't previously get. So that's a key point to kind of bear in mind. So I spent 2.5 years as a strategy consultant at Deloitte whilst working up the business, and drones weren't good enough in the commercial sphere to use in a B2B environment, particularly not for kind of oil and gas and serious industries like the ones that you work in. There was a Chinese company, well, actually a guy in Hong Kong working out of his bedroom, and we kind of assessed his drones. They weren't quite good enough. They're now worth $10 billion. It shows you how quickly it's grown. That was DJI. But in January 11, things got good enough for us to kind of launch the business officially. And what we saw in different markets was interesting. So we looked at agriculture, we looked at quarries, we looked at all sorts of different things, utilities, and we worked in all these different markets to actually see what the business problem was, what we're actually trying to solve by getting the data, and kind of what the real margins were and the pain points. And it struck me when I looked at oil and gas, having known nothing about it, this was the first thing I saw, which was a guy hanging off a rope in the North Sea in January. Now, the thing that struck me first of all, as someone who loves to surf, is that water is probably about 7 degrees. All right? There's probably a howling wind, and he's got a camera in his hand, and that's the best data they were getting on the condition of a critical asset that's sitting out miles away in the sea getting corroded every day. And it just struck me as pretty balmy. So That person then writes a technical report, which is completely subjective and varies in quality. And then they'd put that in. So that was the kind of industry we walked into back in 2011. So we just replaced the person with a drone. And rather than taking 8 weeks for a full inspection by rope access, we got the same amount of data, actually better data, in 5 days. So we drove an efficiency of 85% immediately, which is pretty crazy. I mean, that's a big, big efficiency. Far fewer days of people at risk, far fewer days of people on a platform, so you got all the bed space, far fewer helicopter transfers. So it all actually compounds to a pretty significant savings straight away. And that was just before we even started. So we then thought, okay, well, how can we really get this moving and get the industry to accept it? Because there's a lot of things you have to do. So we brought in industrial experience. So we created an engineering manager role, so someone who has 20 years experience creating the scopes of work, everything from all the inspection packs to actually making sure they happen. So we hired in a former OIE, actually, who's got a background at Lloyd's Register. We then worked across the world, so to date worked in 21 countries, including that 46th 333 exemption. That means that we were the 46th company to get a license to operate in the United States, which is pretty amazing. For a small UK-based company, we did the first offshore inspection in the Gulf of Mexico. We then brought on some of our technologists because we were going out, collecting loads of data, but then we had to do some things with that data. How could we prove that the picture or the image we took of a rig offshore Malaysia, how can we say that that digital image relates to that corresponding piece of the jacket or the hull of a vessel? Right? So we had to work out how can we take all the metadata, i.e. the GPS position of the drone, the angle of the camera, the time and date stamp, and mesh it with a digital image, because that's really important, particularly from a loss adjusting point of view. How do you know that that was in that condition at that time? So it was a way of thinking through the problem before we got asked the question, because we knew that was going to come at some point, that we would be kind of asked, or someone would rely on what we'd put forward as kind of evidence for the condition of the asset at the time. So it's quite interesting, some of these problems. On a more practical point of view, I think our newly hired engineering manager almost had a heart attack when we brought back 12 hours of footage from 2 weeks offshore Malaysia for him to review. And then looking at how much he costs, I almost had a heart attack as well, because you can't charge clients too much money. So we had to work out how we can automate the process of going through all this data, pulling out the really important bits, and enabling engineers just to focus on those bits alone and not have to look at everything that's there. So these real world issues gave us a focus for what we had to develop in terms of the technology. So we brought in our technologists, we brought in a highly experienced CTO, kind of background in B2B applications, from building servers in the desert to setting up mobile communications networks in the South Pacific. So someone who really knew what they were doing, but delivered most importantly in a B2B environment. And I think this is a key differentiation. We brought pilots out of the military, and we've since then set up our own training school. And we brought industry specialists. So our product managers spent the last 13 years at DNV, GL, doing their products. So we knew what the industry required and how they normally work with software and purchase it and everything else to make sure we hit those standards. Which kind of takes us to where we are today. And we're actually doing a huge amount. So this is an example. So we previously, on that last slide we just saw about drones, we were talking about standards. Now this is something that we work tirelessly at, even if the standards bodies are the slowest people I've ever worked with in my life. We've been engaging with them for over 4 years, and only last year did Lloyd's Register put a standard out, or a guidance note on the use of drones. That was written by us. We've got BP, TACA, Woodside, and one other, names escapes me for the minute, to comment on that paper. And actually it was done, and Lloyd's observed us working in the Keppel shipyard in Singapore, doing something pretty similar to this when we're doing a survey. So just kind of an example of the guys at work here. If you look closely, you can see the drone up against doing a hull survey. The guy nearest here is the guy flying. The second guy is an inspection engineer. He's got first-person view goggles on. He's controlling the inspection. So he's talking via a Bluetooth headset, and operating the camera independently of the person flying the drone for safety. So it means that they can get there and they're always in line of sight. There's obviously a lot of interest, people filming us. Always within line of sight, which means that the inspector, the person who is the expert on either that asset or that particular point, is controlling it, which is really important. And so what we were thinking is that when we first looked at how inspections and survey and things are done, was why are things time-based? When you've got a structure out in the North Sea or a structure out offshore Malaysia, why do you only inspect that structure once every 2 years based on some engineering theory? When it's really expensive to mobilise someone to go out, to have a look at it, you get the results back, you put a PDF report in. One person typically will look at that, or a couple of people within the department, and then that gets put in a drawer and it's not accessed anymore. Whereas that information is really important for other people, other kind of users within the business. So it might be that someone in the integrity team has commissioned an inspection, which he does on a 2-year cycle, but then 6 months later, someone from the projects team might be planning an upgrade, but they don't have the latest information on the condition of the asset, yet that was purchased 6 months earlier. So we were kind of thinking, well, all right, how do we make this much more efficient? Because there's probably 65 users for every individual bit of data we get. So we focused on making it ubiquitous within the company. So we created a cloud platform, which means that everyone within the company can access the latest information and see it immediately. So you don't have to have all these time-based trips offshore. You can actually just be collecting the data in a much more efficient manner, and everyone can be accessing that data and doing different things with it. And then don't put the report in the drawer, but keep it. That data is really important and it's worth something going forward. So if you can see what the asset was like 2 years ago and you know what it's like now, should you only inspect it every 2 years when there's a critical failure, or can you start to think about predictive maintenance? Can you start to think about, actually over 6 months, this crack changed by this percentage to this size, therefore should we do something about it in the next 4 months before we have a catastrophic failure, or we have to do some serious, significant intervention, which is very expensive because this is the critical environment that we work in. So this is an example of our portal. So you log on, you can see your assets wherever they are in the world. Obviously they do move. You can view on them. We have a 3D model of your asset. And what we do is we overlay the problems on the asset. So not only do you see where the problem is, you can actually look at it. So there we are. We've applied the assets. You can do it by year or function or whatever. You click on it, and in the top right, you can see the associated imagery with that problem. It's just a really powerful way of interacting with your asset, as opposed to just looking at an isolated picture and not knowing where it is. So we're trying to make it much more intuitive. And the brief for this actually was, if it's not as easy to use as an iPhone, we've kind of failed, because every other piece of software I've ever seen, particularly in the engineering world, is really heavy, and I can't use it because I'm not an engineer. Which I think is a little bit of an advantage when we're trying to create these things, because we're trying to make it easy for everyone. So this is pretty neat. I mean, so far this is kind of pretty game-changing in terms of how people are now interacting with our assets. So let's say we found a problem on this flare boom, like with some through corrosion or something like that. You need someone else to repair it. So you've got another third party who are asked to go out there, some rope access technicians, and go and fix it or do a weld or something. Well, typically they would do a pre-inspection, and they'd have to shut down the platform. They would go out, they would need to plan what tools they have, they'd only be working off a PDF. Instead, they can look at this very easily, they can get all the information they need, plan for the job, everything is there, and they can go off and do it. So you've got other users that are interested in this. Similarly, a structural engineer is interested for, if there is through corrosion, is it on a joint that matters? Is that a load-bearing joint? Because obviously that really does matter. So having it tagged exactly where it is in time and space is really important. But that's only kind of one bit of the story, I guess. And the next piece is, but we have a piece of through corrosion, let's say, on that flare boom. We don't know how big it is, because typically the rope access technician may have been holding his foot against the flare boom and taking a picture. But you think he might have done that, but he might have been 20 foot away. And can he remember when he's got 1,000 individual photos when he's back, safely on the rig having a cup of tea? Does he know which one was which? And so you lose perspective. I actually witnessed someone in an unnamed oil company using a ruler, integrity engineer, using a ruler on his computer screen to try and work out how big a piece of corrosion was, which I just found fascinating, to put it bluntly. So we got some other ways to do it. So computers are really powerful. They can do some great stuff. So we invented this laser measurement, which is a device we put onto the drone, which this is a very old version of it, which fires 2 dots, paints them over the video. In this old version, we had to line them up. Now it's fully automatic. It's a class 1 eye-safe laser. And by lining that up, that gives us an accuracy or an accurate measurement. So we can measure things to sub 1 millimetre. Right, so much more accurate than a person, even on the structure with a ruler, will be able to do. And so we can then do measurements. We can then look at things, how things change over time, which is really interesting. Oh, and that's for not just a flat surface, I might add. It's also for a curved surface as well. So I'll replay this one piece. I was still talking. I was a bit slow. What I'm about to show you here, this is really neat. So video data is, you get a lot of it, and what you don't want to be doing is doing the inspection like the one I referenced in Malaysia, finding the anomalies, tagging them to the 3D model, but then having to look at another 10 hours of footage the next year to find the same problem, because that's a waste of time. So what we do, we invented something called fingerprinting. So all you do here is you say that joint in the top left is the piece you're really interested in. You click on it and say fingerprint that. So what we do is the computer, when it looks at something, let's say, take an example behind me, this wood panelling, if it was in centimetre squared blocks, say just a metre squared of it, and I asked anyone here in the audience to put it back together in the right order, it's pretty difficult. You'd spend hours looking at the different grains and stuff. But to a computer, that is, every single centimetre squared is so different, because it's just a series of ones and noughts, right, with a unique pattern. So all we've done is leveraged the power of a computer to recognise different patterns and lots of points within the image. So the computer doesn't care what it's actually looking at, and things can change. So that image in the top left is the original image from 6 months before, and then all we've done is ask the algorithm to scan over video, right, to try and find the same image. And you can see here it's server-based code on the bottom left, and it's just going through and it's picking out similar images, and it will just find the best match, which it eventually does, and it pops it up. There you go. It's from a different angle slightly, and it's at a different distance from the object. Because obviously you don't want to have to try and fly a drone exactly the same every single time. That would be really difficult. So what we're using here is just using the power of computing and normal kind of image processing methodology and just bringing it into this environment. Because we're going to collect 10x more data every year. And what you don't want is to be seeing and trawling through that data every year. You want to focus on the bits that are really important. Because we can measure things, it means we can do other stuff pretty accurately. So corrosion analysis is really neat. This is an example. We've got our own testing facility, and this is just where we've taken some corrosion from 6 months ago, and then we've got corrosion from a real life, this is, from this year. And you can see, you can then, because you know the difference in change, you can forecast, going forward. You can see, obviously, it's quite a long time ago we did this, but you can then forecast using the empirical data how much it's going to change in another 6 months. And if you look at the far left image, this is actually all real, you can see there's a bit of spray paint on there, which on the second image is now corroded. So it's really clever. It still knows that that's the same piece of corrosion. So we're using stuff like edge detection software and all these other things that we've written in. So it's really neat. So it doesn't have to look exactly the same, and it can take into account other problems and other things that have changed on that image. But by putting them all together and sort of meshing all this different data, it's really powerful. And I'll show you in a minute what we can do. But we already had a few businesses, particularly maritime, when we're doing some internal tank inspections. One of the things they're doing is saying the percentage coverage of corrosion. And I challenged the pretty senior engineer in the room and said, how do you do that now? And he said, well, typically I look at the report, and if it was 10% last year and I have a look, I'll probably write 11%. If it's not that much different. But it's very hard to quantify, and I think that's the point. So using this type of methodology, it's not giving you the answer, it's just giving you some more output to make your decisions as the experts easier. We're not trying to replace anyone or solve anything, because we don't have 20, 30, 40 years of experience. What we can do, though, is give you more data outputs to enable you to make those decisions with more clarity. And this is the stuff that's coming down the line. This is really cool. So this is it's actually a brand new, very expensive FPSO, and this is in one of the storage tanks. And this is an example of kind of how we think and where we're kind of going in the future. So this is not here at the moment. This is something we just did. The picture on the left is a picture of some damage, and it's inside of a tank. So it's steel on steel. And the question we had was, can your drone get imagery that good? And when we kind of thought, well, that's not really the right question to be asking us, because the tanks are pretty big, and you're going to have to watch every single minute of that, and you're going to get fatigued, and you're probably going to miss things if it's that difficult to spot. So we said, can we identify cracks and anomalies using a computer? So on the right-hand side, that's our algorithm identifying the problems, which are highlighted in red. So we haven't spotted that, the computer spotted it. So when you are doing big surveys of big areas where there's small problems, especially on new build, we don't want to be sifting through that data. We want to find this, present it back, and highlight it to the expert on board and say, is this a problem? Because if it's not, you just say, no, that's not a problem. Or if it is, yes, bang, you've got it, and you can then investigate it further and know what it is. So this is kind of, before we put things out in the open, this is kind of where we do all our stuff. That's our own little rig, which is quite cool. And you see the two pilots on there, your good eyes next to the flare tip, which we actually light and doing. So we do all the testing in a real world environment. We have our own vessel there, surrounded by a little bit of water. We have our own tanks. And so we do, everything we do is in a real world environment before we kind of take it out. And we have more stuff coming down the pipeline. So again, future stuff. This is, we've proven it the first bit, which is we can measure the wall thickness from a drone, which is awesome. More accurately than doing handheld NDT, because it goes back to exactly the same spot. That's a real game changer, but we need to do some more manufacturing on that, so it's probably about 6 months out. But it just shows you kind of what's coming down the line. This is something that we're really proud of. This is super, we're really excited. So a couple of months ago, we did the world's first confined space inspection of a tank on an FPSO without putting people in it. This is about a year's worth of work leading up to it. We work with a partner who produced actually the hardware, but we wrap around a lot of software and a lot of know-how to actually be able to do this. So here's a little clip, so you can see it. That's the actual drone. It's pretty cool. It's in its own little cage. It can spin around. It can roll along the floor. It can get into areas that are pretty difficult to access. It's got a thermal camera and a normal high-definition camera on. This is some work we did with B&W offshore. And this is actually the real imagery from that first inspection. There it is, going through the access hatch on its own. You can see there's quite a lot of glare because it's in navigation mode. We've got the lights on full as it drops into the tank. So we have procedures that enable us to map the tank. But first of all, you get your bearings, you go around, and it will just spin around, and you can see that there's no one else in that tank. It's just that. And we had to send a signal through 4 inches of steel, which we'd obviously practiced doing, and worked out a bunch of other things to get that moving forward. And you can see here, this is us looking at obviously doing a close visual inspection, and if you've got a tricky area to assess, the drone can kind of roll over it, which is pretty cool. So it can really get into spaces that are pretty different. And there you go, you got the other side of it as well. And you can see there's less glare back, so already we've been working on some of that. And then for navigation and for the pilots, we also wrap some more software around it. So here is in navigation mode, you've got the reflection, so we take it out. And so now we just ghost the cage around the edge. And that's just our software engineers have written some code, and that's a delay of 1/30th of a second. Now when we're doing this inspection, the guy flying the drone is stood outside of the tank, right, wearing first-person view goggles, and we've got an inspection engineer with him, and they're noting down all the anomalies and locating them as according to how they've done it. It is difficult, that's certain, but it's where we're going. And even if, so the quote back from BW that was, from a safety point of view, this is amazing. And that's our client. And recently, people said even if we went down and did a kind of a summary of what the tank's looking like, that will save hours in people in the tank, which is what obviously we want to avoid until we can get better, until we can do thickness testing and other things. Obviously we can't do that yet, but it's getting there. But already we're making a big impact today. That's just kind of where we are with a couple of our strategic partners, Bristow and Keppel, just to give you an idea of our range. We do a lot of work around the world, and I kind of reference a few of those bits in a minute. And where we're going as a business, you saw the software. We don't want to suddenly try and become, some giant inspection business or kind of get rid of loads of people. We're enabling all of the kind of industry to take this up. So we actually offer this as a service, so you can license our software. You can license all of our know-how to fly drones tomorrow yourselves under 6 years of our learning and experience and best practice. And we have a full training scenarios, both here and the US, opening very soon, that enable you to do that. But that's kind of today. But I guess the exciting bit is where we're going with this, and kind of the industry standards is a big thing. So we do engage with all of the different standards bodies, and this is really important because if we do an inspection and it's not accepted by industry, no one's going to use it really, because they're not going to think, well, if I can't get insured off the back of this inspection, why am I doing it? So we've been working very hard, putting a lot of effort into driving this forward. We actually have inspection or proof with ABS, I think it's next week in Houston, and another one in Singapore in 2 weeks' time. So we're looking to get the first code off ABS for actually, for our procedures and our inspection quality, which is enormous. So that's something we're really excited about. And we're continuing to push that with all of the standards bodies. In terms of other things, there's big regulation changes. So this year, something called Part 107 in the States, which means that anyone can take an online test and fly drones commercially. That's brilliant for American industry. It's taken far too long, but now they're about to accelerate ahead. So that's good. But in countries like Egypt and Tunisia, where we've worked, or Angola, where we're still the only people who've actually worked, we've done the hard work to get that. So if people have requirements there, they can sit under our umbrella licenses and work in those countries. A couple of things I'm really excited about personally is the kind of industrial IoT. We're digitizing all these assets, and we're fundamentally changing the way people interact with their physical infrastructure. This isn't just a small change, this is massive. So right now we're working with one of the top 10 companies by market cap in the States to digitize all of their assets, which is pretty massive for a little UK company in our technology. But it just shows you how they're pushing ahead with this. They recognize that this has a massive bearing, massive savings on safety, on their OPEX spend, and actually on their CAPEX as well. Where we're moving forward, you've got inspection AI, that's artificial intelligence. So some of the things I showed you before about identifying cracks and corrosion and flagging them up, that's really important. But on the software, what we have is when people enter a report in there, we've got predetermined boxes, and we can put in there, this is corrosion type, 1, 2, 3, 4, 5. That gets recorded, and our algorithms, using machine learning, supervised machine learning, know that every time someone tags a certain type of corrosion as corrosion type 1, it learns. What's really cool is if you Google like fluffy white kitten on the internet on Google, fluffy white kitten, you'll get a fluffy white kitten. Google's really good at finding fluffy white kittens, right? If you Google a certain type of corrosion, Google has no idea what you're talking about because no one's trawled that information, no one's found it. So we're building up an incredibly powerful database and knowledge base of all these different types of issues that we face in a B2B environment, in a maritime environment. And so that's not just applicable to this stuff, it's applicable to all your other data. So when you've got people, walking around a vessel, in the future they'll be wearing our helmet cams, they're hooked up to a Raspberry Pi. We know which direction the camera's facing, we know where they are on the vessel. We'll take that data off and we'll just be pre-populating the internal 3D model of the vessel. We'll be inspecting it when they're not without even having to send an inspector there. And we'll be classifying any problems and alerting people to go solve those problems before they're even an issue. And that's where it's all going. It's really interesting. The drone autonomy, that's not really what we're doing, that's what the OEMs are doing. We're drone agnostic, we use the best drones on the market. We work with the leading drone companies in the world and have been for quite a long time. And we're working with them to prove out and to sort out those issues and the proof cases for all that stuff. to go to the final piece here, which is kind of the future, and for us, what we've created is pretty powerful, and it's asset management of vertical structures across all industries. What's really important is vertical structures. It's very different to doing a survey of a field and just stitching it together, or doing stockpile analysis. Vertical infrastructure, and particularly in our environment, is very, very different. We have very different problems to solve, such as thickness measurement, such as corrosion and all that sort of stuff. The continuous autonomous capture and sorting of data. Drones will be autonomous. They'll be on every vessel. They'll be continually flying around. All people will do is go onto the model and go, I haven't seen this week's data for this area, or I'm concerned about that, and they'll click on it. In the background, the drone will do its stuff, even on unmanned platforms, upload the data, and then a couple of hours later, you'll have the answer. That's a massive efficiency, and it's come in quicker than even we think, actually. Then you've got the AI, the automatic image analysis driven output. So what's key here is that the drone will also fly around that piece, and if there's nothing to alert you to, it will just populate the latest model. If there's something to alert you, so if you say, my tolerance for defects or cracks is X, you put that in, and then it will just alert you that, we found a defect that's above your tolerance. Have a look at it. So you don't have to trawl through all this information. And finally, data-driven preventative maintenance regimes. This is powerful. So, why would you? So this is quite a cool stat. So we obviously kept one of our partners, and they make drill rigs. The biggest single line item cost on a drill rig is coating. I had no idea about that until we kind of dug deeper. They coat the whole thing. Why do they coat the whole thing? Well, we don't know at the moment. Is it that everything is failing at the same rate? Is it that critical areas are failing at the same rate? If we've got 4 years of data, we can go back and we can say, well, actually, you only need to coat points X, Y, and Z because it's kind of pointless coating everything else because you're just going to recoat it. That's a massive spend that can just be knocked out by using the data. Often they have this data, but it's in someone's drawer, and it's very difficult to look at it, do the time analysis, and look at the output. It's just a simple business analysis. We're just providing this so you, the experts out there in the audience, or you people can get this information and say, well, actually, this is a problem or this isn't a problem. We don't do that bit. We're just helping you get there. And that's where it's all going. So rather than having people doing the physical surveys, we'll be having people who have all that experience of doing the surveys, doing what we call the really high value, really high quality stuff, which is making the decisions and doing the advice on what needs to happen in the future. This is where we have today, and I was talking to a company that hire PhD students straight off their PhD, and a lot of them go gather data, which I find, walking tracks and looking for bushes that are coming too close to the track. I mean, that just strikes me as crazy when you've got someone that's this smart, being used to do those kind of menial tasks. So data gathering is a pretty low-value job in terms of the grand scheme of things, and sorting that as an action. Action's really where it's at. So by enabling the automation of everything, we move to this model, right, which is far more powerful. So you've got analysis and action continually happening, right, which obviously optimizes assets. And if you think about anything that's floating or fixed out in the ocean, the more uptime you get, the longer it lasts, the more preventative maintenance you can undertake, the cheaper it is to run, the more efficiency you get, the more money you make. It's really simple. And so this is what you'll see. You'll just be logged on, you put on your VR glasses, your virtual reality goggles, and you'll see your rig or your vessel, and you'll look around it. I literally just came from a meeting where we were talking about new builds and creating 3D models of new builds and clicking all the IDs. So as they get built, and then the operator takes them on, there's an issue, they just click the ID, they can go into the model, someone can then immediately know exactly what needs replacing, and if there be an issue with moving it or putting it somewhere else. Just really basic stuff, but that doesn't happen today. And that's it. That's the future in about 25 minutes. Thank you very much.
Stay there for a couple of minutes. We have got about 7 minutes before lunch. I just wonder wonder, I mean, you've given, I think, everybody in the room an insight into something that we frankly know almost nothing about, I suspect. I just wonder if you've got any questions, if you're happy to take a few questions.
Absolutely.
Is there any questions? Okay, let me mic you up.
Could you, the motive part of these drones is what?
Sorry, say again.
The motive part of them is what, electric or?
Yeah, so we use so electric, and so I think, and I'll kind of answer the next question, which is where we come, which is no, they're not EX rated, so they're not explosion proof yet.
Yeah.
Particularly for the internal tank, there's two things we've got to do there. One is it's got a cage around it, so it does collide into things. And the other one's it's got, you know, the parts, i.e. the props and everything that moves. We've done everything we possibly can to make it as low risk as we can. We've got procedures in place to make sure that we mitigate the risks as far as possible. We work under, you know, hot sparks permit tickets and things offshore. But also for internal tanks, we're looking at other solutions such as flooding a tank with inert gas and other things to mitigate those risks. We certainly don't arrive with a 100% solution today. But what we do is make pretty significant strides towards getting there. And I think that's the kind of biggest thing we can do. And that's where we're looking, obviously, to industry to help us and guide us, because we're not the experts in all things, and we absolutely need your input to help us help you.
That touches the other point I was going to make.
Yeah.
Can they go through pipelines?
At the moment, in terms of what we use here, we kind of haven't really looked at the kind of market where you've got pigging and stuff going on already. So that's not really our area. I will say that we're doing some beyond visual line of sight things, although that's kind of not the kind of case for what I've showcased here. But I think that's still a way off, and I don't think I would see us going inside of pipelines. I see us doing external kind of inspection and using our techniques, coupled with other people, to come up with new and novel ways of doing things.
Thanks. There was one other thing. My colleague at work came out the other day, drones down in Felixstowe Port. Yeah.
Well, they've been used.
The Port Authority won't like that if we come buzzing over the fence with a drone. What sort of regulatory requirements are there?
Sure. So there's good regulations in place from both the Civil Aviation Authority, but also we're creating the industry-specific ones as well. So you mustn't fly over people within X amount of distance of a structure or over crowds. We put in quite robust risk assessments and method statements to mitigate risk as much as possible. If it's private land, there are different concerns, obviously some privacy issues, but we've been dealing with those for the last 6 years. And every country is slightly different, but we have helped some governments around the world understand what the best practice looks like, and they've implemented that as the standard.
Can you link, since most of our concern of marine surveyors is with regard to hulls of ships, and the hulls of ships are approximately 1/3 above water and 2/3 below water. Below water extensions can be done by ROV. Can you link ROV data with your other data and give a 100% analysis of hull conditions?
That's a great question. So, and when the mini ROVs, even more so, are making this a really interesting area. The simple answer is yes, we can. However, I have a fairly small team. I have 16 developers, so it's not on the roadmap for this year. Next year, we may start bringing that in, so you get the complete picture. But it's just a case of time. There's absolutely no reason why we can't take the same metadata off the ROVs, doing the hull surveys and mesh them together. Because absolutely, and you're not the first person to say this, but you're absolutely right, it's a very powerful solution for hull surveys. And every time I fly into Singapore, you fly around before we get to Changi, I just look at all these vessels and just think, we could be inspecting all that now, as opposed to having them in port or out in dry dock and wasting loads of time and effort, when we can have it, done more regularly for far cheaper the cost.
Hi, it's me from Dynamic Surveys. Taking from the small inspection ROVs, and then you've got the work class ROVs, How far are we away from the drones that actually produce larger drones and actually do minor repairs, say on a leg or an oil rig or something like that? Is that dreaming or is that on the cards?
No, with the speed of technological change today, nothing is dreaming. It's the kind of, we're really at the cutting edge, and things we're surprised pretty continually. I mean, we're assessing new things every week, literally. It's amazing. Robotics, we see there'll be, we already work kind of fusing aerial data with crawlers. You know, and that we certainly see on a vessel, on a rig, crawlers going down and doing work. You know, if it's magnetic or kind of via a tether. In terms of physically getting the drone to attach to things, there's no reason why, the same way the ROVs developed to do the fixing themselves, there's no reason why that won't happen fairly quickly. It will come down to what types of things they're doing with what accuracy they can do it. Interestingly, where we're going with what we're calling kind of native drones, where they'll be sat on every vessel and completely automated. They can fly in any conditions they want. They can wait till the conditions are amazingly calm, beautiful light, and then they can go up and capture that data. And so I think the first drones that are fixing or doing repairs will be very similar and using the most benign conditions to do it. Because actually, we don't need to go out when it's 4, 6 or whatever. We can, although we do now, because we have to go out when the client's got a window. But if it's there the whole time, it can be done. But I'm not going to stand and give you a timeline. I think that would be too difficult. But I think it won't be too many years away.
Time for one more question. Anybody want to ask anything else? One at the back. Okay.
This is rather a practical question. When a surveyor is looking at something, he often has to clean the area, particularly in tanks. You've got shadow areas which are very difficult. Have you thought about fitting something onto the drone that would enable this, like an arm or something that would wipe the area or clean off some loose rust so you can actually get a good picture of what's underneath?
Yeah. That's a really good question. I think at the moment for the confined space inspection drone, it's fully gimbaled, so you wouldn't be able to attach it to the outside. We wouldn't be able to do that. I think as we develop the solutions, absolutely, that's kind of where we need to go to, so we can kind of do a bit more interrogation, and also with the kind of ultrasonics, attach the drone as well as the thickness. So the short answer is no for the minute, but I think where we are adding the most significant benefit is if we can get around a tank and identify the 5 or 6 areas where you do need to do that, and then someone can get in and at the moment go and do it themselves, we've still made an enormous difference. So the short answer, for the internal confined space inspection stuff, that's going to be very difficult with the type of drone. For external, there's no reason why in the next kind of 18 months that isn't a solution.
I think it's that time, ladies and gentlemen, time for lunch. So if I could just say, well, you certainly give me a lot to think about, James, and like you, I'm not really a technical guy, and I don't get this stuff, but I totally get the ramifications for potentially this profession. The things that just struck me are that the safety implications when you can put something inside a tank rather than a human has to be good things. You've touched on confined spaces. We touched on confined spaces yesterday with MRS training, and I was just absolutely fascinated. So thank you very much for being with us, much appreciated, and we will take a break for lunch and we're back at 2.